Hi everyone, thank you for joining me. Today I'm going to be talking about time series and forecasting models. So, what is time series? Just read that again. What is time series? It is essentially data that's collected at regular intervals. And we're essentially just looking at the relationship between one variable and time. So often we're trying to forecast something about the future. So, why do people even do this? Well, many organizations will use time series analyses to gauge at or predict their performance in the future. So, for instance, we have stock prices, sales, inventory needs, etc. So, the next thing I want to talk about is some keywords. So these are words that you'll hear if you're talking about time series in general. There's variation, trends, there's seasonality, and cycle. So variation is basically just the unpredictability of the data, right? And it's the unexplainable ups and downs that we have. Trends is where the data is pointing to. So it's kind of like the pattern that we see. And seasonality is identifying a pattern, right? But during a set period. So, for example, like toy sales right before Christmas. And cycles is the non seasonal patterns, right? So, these could be like periods, like, for example, recession, right? Which could last months or even years. Okay. Now that we're clear with that, let's talk about some forecasting models. So the first one I want to start off by talking about is ARIMA. And here we have, for example, the AR stands for auto recessive, not regressive. And the I actually stands for integrated, and the MA stands for moving average. So the autoregressive component tells us how values we have collected will affect our prediction, right? So this portion tells us about like future values. The integrated component tells us about trends, like cycles, seasonality, etc. And the moving average component, so this part here, this kind of gets rid of the, random movement and noise. So this model is used where we see some sort of non-stationarity in the data, right? And the equation we have for this is linear, and the predictors are legs of the dependent variable, or legs of the forecast errors. And of course, when we have like models, there are some sort of assumptions, right? So what are the assumptions we have to make here for this model? Well, one of the assumptions is that the mean, so I'm going to write mu here, and variance is constant over a long period, right? So essentially their series is normally distributed and stationary. We also assume that there are no outliers. And we can perform time series analyses with a couple of programming languages. So the programming languages that we like to use to perform these are such as, MATLAB, can use Python. In Python specifically, I would say you're looking to use the pandas library, right? Or we can use, what's that called? Matplot libraries. I think it's matplotlib. Yeah. And so we can even use both, right? So for example, like the pandas library, we can use for processing and cleaning the data. And then the matplotlib we can use to graphically, visualize the data. Okay. So now let's talk about another model. So the other model I'd like to talk about is the GARCH. The GARCH model. And so basically other models are sometimes, I would say, like bursty, meaning that there will be some jumpiness, right? So for example, what do I mean by bursty? It means like it'll be like this, it could be like this. So it's like kind of like really jumpy, as you can see in the graph, which is fine. And some of the other models like ARIMA or ARCH are good at modeling these bursts of volatility. But for more persistent bursts, right? So for more bursts, kind of like, let me show you. More like this. Maybe we have, as you can see, these are still bursts, but it's like for a longer period of time. Like this period of time is a little bit longer. For this, we can use GARCH modeling. So an example would be pretty helpful here. So we can use this type of model for something like forecasting how much a stock is jumping. So the volatility over time. And when trying out this project, a good stock to pick for this model, I would say, is probably one where you can observe some sort of periods of high volatility already, so we can get an expected result, and then we can use the model for other stocks once we're sure that our model does what it's supposed to. And so that was a brief overview on time series and some models that can be used. I hope that's helpful, and in the future I can even delve more into depth about some of these models if that's something you guys would like to see. Thank you.